Every day, millions of vehicles navigate the dense, high-stakes intersections of Bangladesh, between private commuters, massive logistics fleets, and a rapidly expanding ride-sharing market. The physical volume of traffic is immense. But despite the sheer number of cars on the road, almost every driver is operating with a massive blind spot. They are navigating without any real-time data regarding the internal health of their engines. Because drivers cannot see a slow coolant leak or a rising internal temperature gauge, tiny mechanical faults go unnoticed. These hidden issues accumulate until they cause a sudden engine overheat or a catastrophic breakdown right in the middle of a journey. Mechanical risks are further compounded by unmonitored human behavior. Aggressive speeding and chronic hard braking put excessive strain on the powertrain, pushing critical components toward failure much faster than the manufacturer intended. The entire transport economy currently relies on a reactive model. Owners drive their vehicles until a part physically breaks or an accident happens, and only then do they address the damage. But the math changes if a vehicle can signal an impending part failure weeks before it actually breaks down. That concept is the foundation of the Vehicle Healthcare AI platform. The platform uses IoT sensors to transform ordinary, disconnected vehicles into self-diagnosing nodes on a wider network. This shift allows fleet managers and private owners to move away from waiting for disasters to strike, relying instead on continuous telemetry to predict and prevent mechanical failures. Accessing these internal metrics starts with a physical port built into the dashboard of almost every modern car, the Onboard Diagnostics, or OBD-II port. Plugging a low-cost Bluetooth adapter or custom hardware device into this port connects directly to the car's brain, the engine control unit. In the first active step, the device pulls live metrics from the engine, logging temperature, RPM, fuel consumption, and voltage. Once collected, this raw telemetry is instantly streamed via Bluetooth or 4G networks to both cloud servers and the driver's mobile device. This mobile interface displays the final visualization step. Complex telemetry is translated into specific measurements, like intake temperature and battery voltage, creating a clean, readable health status for the driver. Together, these three steps provide the driver with a live digital X-ray of their vehicle's internal condition while it is in motion. Displaying raw data is only half the process. The retrieved OBD-II values are fed directly into a machine learning processing block. By cross-referencing this incoming telemetry against historical data, the AI calculates engine failure probabilities and flags anomalies indicating imminent mechanical danger. At the same time, the system monitors the human element. It flags hazardous driving behaviors, keeping an exact log of chronic hard braking or rash high-speed maneuvers. When the AI detects a critical fault or a dangerous driving pattern, it pushes a smart notification to the driver's phone, advising them to stop or repair the vehicle before an incident occurs. By continuously analyzing both mechanical data and driver habits, the platform identifies high-risk patterns and intervenes before they result in a collision. When this technology is applied to a heavy commercial truck or a logistics fleet of 100 cars, the economic impact multiplies. This dashboard layout shows the fleet management system. It acts as mission control, pulling health data of hundreds of vehicles into one view. Zooming in, managers see the precise GPS breadcrumb trail of any vehicle for live route tracking. This visibility enforces strict financial control. By tracking fleet-wide fuel efficiency in real time, managers can instantly spot unnatural drops in fuel levels, which helps identify and prevent fuel theft. The AI also automates maintenance. Instead of guessing when a truck needs service based on a calendar, the system schedules garage appointments based on the actual, measured wear and tear of the engine. At the enterprise scale, this sensor network replaces sudden, costly breakdowns with predictable, highly controlled logistics. That intelligence extends to the wider commercial ecosystem. The system integrates directly with local garages, sending them diagnostic reports so mechanics know exactly what to fix before the vehicle even arrives at the shop. It also manages administrative requirements, automatically tracking and reminding fleet operators of upcoming BRTA fitness checks and insurance renewals. For a fleet operator, a single undetected engine overheat can lead to a full overhaul, costing hundreds of thousands of taka in parts and lost revenue. By catching these faults early across dozens of vehicles and eliminating fuel theft, the platform prevents millions of taka in annual losses. Turning reactive repairs into predictive intelligence makes transport logistics more profitable. But more importantly, it keeps hazardous vehicles off the street, making the roads of Bangladesh safer for everyone.